Today I'm going to be showing you how you can build your own Arduino on a breadboard. So it's very straightforward to do with a little bit of practice. Okay. Well, the first thing that we're going to be looking at though is this is our power supply. Okay. So I'm using a 7805 voltage regulator here. Okay. So I'm going to be taking 9 volts in and getting 5 volts out, which I'm going to be connecting to the positive side of our power rails. Okay. So I've connected our power rails here to these power rails up here, okay, and I have 2 capacitors here. This particular one here is 10 microfarads, and it's connected from the input to ground, and this is 1 microfarad is connected from the output to ground. These capacitors are polarized, so it's important that the negative side is connected to ground, and the negative side is the side that has kind of like a stripe on it. Okay, and I've included this LED in here just to basically tell us that the power supply is actually getting power, okay, and it's working. Okay, so it should turn on when I connect up the battery. Okay, so this is the Amiga 328 microcontroller. Okay, so this is the type of microcontroller that you will see in Arduino Uno. Okay, so this is pin 1 here. Okay, this is pin 1 because the microcontroller has a little notch here which indicates that that's pin 1. Okay, so now to connect it up. So the first thing that you do is you connect pin 7 to 5 volts. Okay, so if you look at the pin layout of this microcontroller, you'll see that pin 7 is VCC, which means that you just connect it to 5 volts. Okay, so I connect that now. Let's see, 1, 2, 3, 4, 5, 6, 7. So there you go. That's connected to 5 volts. Okay. The next thing you do is connect pin 8, which is ground, to ground, like so. Okay. So pin 9 and 10 is where you would connect your 16 megahertz crystal oscillator. So you just connect it like so, just pin 9 there to pin 10. Okay. And the next thing then you would do is you would take a 22 picofarad capacitor, you would connect one leg of it to pin 9 and the other leg to ground. Okay, you take another 22 picofarad capacitor and you connect one leg to pin 10 and the other leg to ground. Okay, like so. Okay, and that's it there. Okay, now we want to, in the sketch that I've uploaded to the microcontroller, I'm using digital pin 13. Now if you look at the pin layout, you will see that digital pin 13 is located at pin 19 of our microcontroller. Okay, so if I count that now, let's see, 15, 16, 17, 18, and 19. So there you go. So just get a jumper wire, connect that to from pin 19 to an empty part of our breadboard. Okay, like so. The next thing you want to do is take a 1 kilo ohm resistor and connect that here like so. Okay, so it's connected up there. Okay, take a red LED or any other color LED like so. You connect the longer leg, which is the anode, okay, to the resistor like so. Okay, the shorter leg is the cathode, which you connect to ground. Okay, like so. Okay, and that's it. Okay, so when I add the 9 volt battery, okay, we should see this LED here flash on and off for about a second. Okay, so let's see. So that's ground connected there, and then our 9 volts to the input, and there you go. Okay, and that's basically it. Okay, so when you want to upload sketches onto the microcontroller itself, what you need is one of these. Okay, this is a USB to serial converter. Okay, so if you connect this into an empty part of our breadboard like so, okay, it has 6 pins. Okay, so the first pin here is ground. Okay, and you just connect that to ground like so. Okay, So the second pin is called the CTS pin, and that is left unconnected. Okay, so you don't connect anything to it. Pin number 3 is our 5-volt pin, so you connect that to 5 volts, like so. Okay, so at this stage you can see the USB to serial converter light up. Okay, the fourth pin is our transmitting pin. Okay, and you connect that to the receiving pin on the microcontroller, which is pin number 2. Okay, like so. And the next pin is pin number 5, which is our receiving pin. Okay, and you connect that to pin number 3 on the microcontroller, which is the transmitting pin. Okay, like so. Now, the sixth pin is called the DTR pin. So what you do is you take this is a 100 nanofarad ceramic capacitor, and you connect one leg of it to the actual DTR pin and the other leg to an empty row here on the breadboard. Okay, you take a wire like so, you just connect that all the way to pin number 1 on the microcontroller, which is the reset pin. Okay, and finally what you do is, this is a 10 kilo ohm resistor. You connect one leg to pin number 1 on the microcontroller and the other leg to 5 volts to our 5 volt rail here. Okay, and that's it. Okay, and so the next thing then is to just upload your sketches then, where we're using, this is our USB cable, and the other connector is connecting to my laptop. Okay, so what you do is you just you simply just connect it up like so, like that. Okay, so you can hear that little noise. That means that it's connected up there. Okay, and that's it. And that's all you do. Okay, so as it stands, you can use any of the digital pins on the microcontroller. If you want to use the analog pins, you have to make a connection. I believe it's pin 20, which is the AVCC pin, to 5 volts. Okay, and the AVCC pin is a separate supply voltage for the analog to digital converter that is built into the microcontroller. Okay, and that's all you do there. Okay. So this is the sketch that I uploaded onto the microcontroller before I explained how to connect it up. Okay, and what I've done here is I've just written a few lines here to tell you what each of these lines of code why they're in there. Okay, and if you don't want to write this out, you can simply just go here to examples and then to basics and to the blink sketch. And these are all pre-installed. Okay, when you download the Arduino software. Okay, so you just click on the blink sketch there. Okay, and that's it.